Okay, Budit. We can start today's class then. First, we are going to do unit in dimensions part. Then the final 1 hour will be allocated for basic mathematics lesson today. That is additional 1 hour. So now we can start unit and dimensions part. So up to now we have discussed about dimension. So what is a dimension? Then how to write a dimension. Those are the things that has been discussed in previous class. So today we are going to discuss about some applications of dimensional analysis. Some applications of dimensional analysis. Therefore, this should be written in your dimensional analysis book. Actually, you have to maintain 2 books as I mentioned you earlier. One is for basic mathematics, other one for physics theory part. So this one should be written physics theory book. Then, right, this is my first topic of today. Applications of dimensional analysis. Applications of dimensional analysis. Today, you know what is a dimension, no? So what is the dimension? What is the dimension? What is the dimension of a physical quantity? What is the dimension? What is the dimension of a physical quantity? Can you tell me? What are the dimensions here? Actual dimension means that is a symbolic representation. No, it is a symbolic representation of a physical quantity. Actually, that is symbolic representation of the relationship between a physical quantity and basic physical quantity or fundamental physical quantities. And so, when we are writing a dimension, the first thing we did. Actually, we have defined dimensions for fundamental physical quantities. In that case, there are 3 main fundamental physical quantities: mass, length, and time. So we have defined the dimensions of those physical quantities first, because those 3 physical quantities are involved with most of the derived physical quantities. Okay. Sometimes other basic physical quantities also involve with some derived physical quantities, but those 3 are the main things. Okay. Therefore, we have defined dimensions mean that is a symbolic representation only. This is a symbolic representation only, and therefore, first we have defined the dimension of mass, length, and time. Mass, length, and time. Dimension of mass. As I mentioned you earlier, dimension can be represented by square brackets. Therefore, if we want to write the dimension of some physical quantity, you have to mention it within a square bracket. Therefore, this means dimension of mass, that is n. Then dimension of length is equal L. Dimension of time is equal capital T. Capital. Then, using those symbols, we can determine the dimension of certain derived physical quantity. Dimension means there is a symbolic representation of the relationship between that physical quantity and fundamental physical quantities. And, okay. Then we have written some dimensions with it as an example, dimension of velocity. Dimension of velocity can be written as, first we have to write the relationship with it. Yes. First, you have to write the relationship between the particular derived physical quantity and the basic physical quantities. Here, velocity means displacement over time. So once you write down this relationship, this means actually this relationship means this is the relationship between the derived physical quantity and the basic physical quantities. Displacement means that is a length. Therefore, dimension of a length is L. Dimension of time is T. Therefore, we can write the dimension of velocity as LT minus 1. When you are writing a dimension, you have to take all the terms. You have to take all the terms in the denominator into the numerator. Therefore, when you are taking the denominator into numerator, its power will be negative. Therefore, you have to mention the dimensions of a physical quantity in this way. Okay. So this is the thing that we have discussed in our previous lesson. Now, today, we are going to do some applications of dimensional analysis. This is the most important part in dimensional analysis, the application thing. So you have to listen to this lesson very carefully. If you have any question, please let me know, because this is the heart of this lesson. Therefore, today is the most important day regarding this lesson. So today we are going to study about some application. So when we are doing some application, first, before we are doing application, we have to study some rules. There are some rules in dimensional analysis. So first of all, we are going to study about the rules of dimensional analysis rules. But you have to listen to that lesson very carefully, because there may be some actually, if you have anything to ask, please clear all the things before completion of today's class. And okay, the first one. Suppose we have to add or subtract two physical quantities. If you are going to add or subtract two physical quantities, definitely those two physical quantities should be equal physical quantity. That means they should be the same physical quantity. And that means you can add or subtract. That means addition or subtraction can be done among same physical quantities only. That is the first rule. Bhute. This is mentioned in your note, Bhute. No need to write it again. Addition or subtraction can be done among the same physical quantities. Addition or subtraction can be done among the same physical quantities. No need to write. So what is the meaning of this? Suppose this one. Suppose you have to add 1 kg sugar to 1 kg sugar to 10 seconds. Can you add 1 kg sugar to 10 seconds? Can you? Can you add 1 kg sugar plus 2 seconds? Can you add? Can you? Can't. කරන්න පුළුවන්ද මේ addition එක? හා? sugar නැත්නම් මේ sugar kilogram එකකට මේ පාට add කරන්න පුළුවන්ද මේ time එකකින් 10 seconds add කරන්න පුළුවන්ද? No, you can't. You cannot add. Huh? Not even adding. Actually, you cannot subtract. You cannot subtract 1 kg. You cannot subtract 2 seconds from 1 kg. You cannot subtract 2 seconds from 1 kg. Therefore, this cannot be done with it. This cannot be done. But if you can add 2 kg to 5 kg. 2 kg to 5 kg means kilo. That's a 2 kilogram of something, and you can add 5 kilogram. Then answer is 7 kilogram. Okay? 2 kilogram minus 1 kilogram, answer is 1 kilogram. Therefore, you can add or subtract, or addition or subtraction can be done among the same physical quantities with it. But they cannot be done between two different physical quantities. Therefore, if there's an addition or subtraction, this is the most important thing. This is the most important thing. If there's an addition or subtraction, these two physical quantities should be equal. Should be equal. In other words, that means if there's an addition or subtraction, their dimension should be equal. If there's an addition or subtraction, their dimension should be equal. That means if there's an addition or subtraction between two physical quantities, definitely these two physical quantities should be equal. They should be equal. That means, in the other words, that means if there's addition or subtraction, that means those are two same physical quantities, Putin. Therefore, their dimension should be equal. Their dimension should be equal. Is that okay? Did you get my point? If you get my point, please raise the hand. I need responses from everyone. Yeah. Therefore, this is the first rule. If there's an addition or subtraction, definitely their dimension should be equal. The dimension should be equal. The second one, the second rule. First rule addition or subtraction. If you get the first rule, please raise the hand. If you get the first rule, please raise the hand. Because I need to understand the thing. Therefore, if you can respond me, it will be much better. Because there's an application. There are some applications for there. Therefore, you have to understand that thing very well. Thank you. If any student need to explain it again, please let me know. If any student need to explain it again, please let me know. That is the first rule. The second one. Suppose now there's an equation. Suppose there's an equation. Before doing this thing, I had to mention. The addition or subtraction cannot be done among two different physical quantities. But multiplication and division can be done. Multiplication and division can be done. Give me an example. Addition or subtraction can be done among two same physical quantities only. But multiplication or division can be done between two different physical quantities. Give me an example. You know, all the examples. There are a lot of examples. Even though addition and subtraction, actually they can those operations can be done among two similar physical quantities only. But multiplication or division can be done among two different physical quantities. You asked to give me some examples. We had a lot of examples in orders. I need someone. I need something. Not all of them. At least 2 or 3 examples. Go. මට addition එකයි subtraction එකයි පුතේ two different physical quantities වලට කරන්න බෑ. ඒ වුණාට multiplication එකයි division එකයි කරන්න පුළුවන්. මම අහන්නේ examples. හරිද? What are the examples? Can you multiply mass and acceleration? Can you multiply mass and acceleration? Yes, Chris. Very good. Can you multiply mass and acceleration? Is there any meaning of this multiplication? Is there any meaning of this multiplication today? Can you multiply mass and acceleration? Oh, I did answers today. I did answers. Can you multiply mass and acceleration? Mass and acceleration multiply කරා කියලා meaning එකක් තියෙනවද? Yes, definitely. No, definitely yes. Mass and acceleration. If you multiply mass and acceleration, you have the force. Yeah? Then one thing. If you divide force or area, by area, is there any meaning? Force divided by area? Yes, that is pressure. That is pressure. Then distance divided by time, velocity. No? On the other hand, velocity into time equal distance. Velocity is into time is distance. Therefore, although we cannot add or multiply two different physical quantities, although we cannot add or subtract. Although we cannot add or subtract two different physical quantities, we can multiply or divide. By multiplying or dividing, we can get another physical quantity. Therefore, Put multiplication or division can be done, but addition or subtraction cannot be done. Okay. That is the first rule. That is the first rule. That is the first rule. Application of dimensional analysis. Rules in analysis. First rule. No need to write it again, write all the things, but you have to write this one very briefly. So if there's an addition or if there's a subtraction, if there's an addition or subtraction, definitely these two physical quantities should be equal. That means their dimension should be equal. No need to write all the things, just write it brief. Although we cannot add or subtract two different physical quantities, multiplication or division can be done. That means, as an example, if I multiply F into acceleration, that is force. This is okay. If I divide force over area, it will be pressure. That is okay. If I divide S over time, that means displacement over time. Displacement over time is equal velocity. On the other hand, if I multiply S into time, if I multiply velocity into time, velocity and time, the answer will be displacement. Therefore, although we cannot add or subtract two different physical quantities, we can multiply or divide. Two different physical quantities. Therefore, the first rule in dimensional analysis is, if there's addition or subtraction, definitely those two physical quantities should be same. If they're same, their dimensions should be equal. No need to write all the things because most of the things are given in our note, but this one should be noted. මීටින් හොඳට අහගන්න පුතේ මොකද මේ ලෙසන් එක තමයි ඩිමෙන්ෂනල් ඇනාලිසිස් එකේ තියෙන වැදගත්ම ලෙසන් එක. මේක තේරුම් නැතුනොත් එහෙම ඩිමෙන්ෂනල් ඇනාලිසිස් කරන්න බෑ. මේක තේරුම් නැතුනොත් එහෙම ඩිමෙන්ෂනල් ඇනාලිසිස් කරන්න බෑ. මේකට ආයෙත් ඔය කතන්දරේ තමයි වෙන්නේ. හරිද? ඒ නිසා මේ ලයිව් ක්ලාසස් මගේ අරගන්න එපා, රෙකෝඩින් මගේ අරගන්න එපා. රෙකෝඩින් බලන්න හුරු වෙන්න එපා මුලින්දලා. මොකද මේ මම එහෙම කියන්නේ රෙකෝඩින් බලන්න හුරු වුණොත් ඒක අතහැර ගන්න බෑ. ඇත්ත කතන්දරේ ඒක. හරිද? කවුරු හරි ළමෙක් රෙකෝඩින් බලන්න හුරු වුණොත් ඒ ළමයා ඒ රෙකෝඩින් එක කරනවා හුරු වෙන්නේ. ලයිව් ක්ලාස් එක කම්මැලි වෙනවා. ලයිව් ක්ලාස් එක කම්මැලි වෙන අපේ හිතෙන් මෙතන කමන්නේ රෙකෝඩින් එක තියෙනවා මම රෙකෝඩින් එක බලනවා කියලා හිතනවා. නමුත් ඇත්ත කතන්දරේ පුතේ රෙකෝඩින් එක බලන්න වෙන්නේ නැහැ. දැන් අපි සාමාන්‍ය මේක අවුලක් නැහැ පැය 6ක් තියෙන ක්ලාස් එකක්. නමුත් නිකන් හිතන්න පුතේ අපිට පැය 3ක පැය 2ක වගේ ෆිල්ම් එකක් එකපාර බලන්න පුළුවන් නෑනේ. අපි අඩු ගානේ ඔක පෝස්ට් කරන්න තු බලන්නේ නැහැ නේද? අනිවාර්යයෙන්ම පෝස්ට් කරලා එහාම එහා ගිහිල්ලා එහෙමද බලන්න. ඒක ඕක තමයි ඉන්නේ අනිවාර්යයෙන්. ඔයාගේ ස්ට්‍රොක් එකක් ආවොත් හැම සබ්ජෙක්ට් එකකම නිකන් හිතන්න පැය 6ක වගේ ලෙසන් එකක් බලනකොට පැය කීයක් ඇවිත්? පැය 6ක වගේ ලෙසන් එකක් ලේසියෙන් බලන්න බෑ ඇති. හරිද? ඒක නිසා මේ ලයිව් ක්ලාසස් මග අරව ගන්න එපා. ලයිව් ක්ලාසස් මග අරවතොත් වෙන්නේ මේ අයි ලේසි නෑ අල්ලගන්න. ලේසි නෑ අල්ලගන්න. අය ඇත්ත කතන්දරේ මම කියන්නේ. අන්තවත් දෙකක් තියෙනවා මේ කොච්චර කට ගන්නම් කිව්වා ඔය වැඩේ කරනවා. වැඩේ කරනවා අන්තිමට කරලා හැලෙනවා. කරලා හැලිලා අන්තිමට කීප දෙනෙක් තමයි හරියට මල්ලගෙන යන්නේ වැඩේ. හරි. දැන් උනත් එහෙම තමයි දැන් ඉන්න ඔය උඩ බැච් වල කට්ටියත් උරුම තමයි මේ විදියටම ඇඩ්වයිස් දීලා තියෙනවා ලස්සන්ට අහලා තියෙනවා එහෙමට පස්සේ දැන් ඉතින් විඳවනවා ඉතින් මොනවා කරන්නද ඉතින් වෙන්න දේ මෙන්න මේ දේ වෙනවා කියලා කලින් කියනවා නමුත් අහන්න නැත්නම් වැඩක් නැහැ ඒ නිසා අනිවාර්යෙන් ලයිව් සෙෂන්ස් නම් අනිවාර්යෙන් ගන්න ඒක අනිවාර්යෙන් ගන්න හුරු වෙන්න මොකද රෙකෝඩින්ග්ස් වලින් ගොඩ දාන්න බෑ මේක තමයි. ඒක තමයි ඇත්ත. එහෙම අපිට කන්සන්ට්‍රේෂන් එක තියාගන්න අමාරුයි. මේක කොහොමද කරන්න අමාරු වැඩක් ඒක. හරිද? ඒ මොකද ලයිව් ක්ලාසස් එකකදී පුතේ අනිවාර්යෙන් ක්ලාස් එක ආව එතනින් ඉහළ ඔයාලට බැලන්ස්ුවක් නෑ. ඔයාලට බැලන්ස්ුවක් නෑ. ඔයා කොහොම හරි මේ සෙෂන් එකේ ඉන්නවනේ. හරි මේ බැලන්ස්ුවක් ආවොත් තමයි ප්‍රශ්නේ වෙන්නේ. හරි. මොකද සමහර පාන සමහර දවස් තියෙනවා ඒ දවසේ උගන්වන ලෙසන් එක නැතුව අතරින් යන මුත් කරගන්න. ඒ දවසේ උගන්වන ලෙසන් එක බැරි වෙලාවත් අල්ලගන්න බැරි වුණොත් ඊළඟ සතියේනවා ඒ විල වැඩක් නැහැ. මොකද ඒවා තියෙන්නේ. ඒ ලෙසන් එක උන විල වැඩක් නැහැ. දැන් වා අදුගාන අද දෙක මිස් වෙනවා. අද දෙක මිස් වෙලා ඊළඟ වීක් එකට එන්න කලින් ඔක බලා ගන්න බැහැ. ඊළඟ වීක් එකට ආවට පස්සේ ඔයාලට මෙල මොකද දාන්නේ තේරෙන්නේ නැහැ මොකද. ඊට පස්සේ ඔන්න එපා වෙනවා වැඩි. ඔක හැමදාම වෙන දෙයක් වෙනම ගත කරන්නේ. ඔන්න වැඩි එපා වෙනවා. ඊට පස්සේ මොකද ඉස්ට්‍රක්ට් වෙනවනේ. වැඩේ කරන්න බෑ තේරෙන්නේ නැහැ. මෙල මොකද දාන්නේ තේරෙන්නේ නැහැ. ඔන්න වැඩි එපා. ඊට පස්සේ වැඩි අතල්ලා. ඊට පස්සේ වැඩි අතල්ලා. මම ඇත්තටම දැකලා තියෙනවා මාරම දක්ෂ ළමයි ඉන්නවා. මාරම දක්ෂ ළමයි කියන්නේ ඕලර්ස් වල 9 years ගත්ත ළමයි ඉන්නවා. ඔය වගේ පිස්සු කියලා. මට අරක නිසා බෑ මේක නිසා බෑ එහෙම ළමයි. බස් සමහර දරුවෝ මම දැකලා තියෙනවා. මට කියලා තියෙනවා සහ මම පැහැදිලිව දන්න ළමයි ඉන්නවා. මොකක් හරි හේතුවක් නිසා සමහරවිට ගෙදරින් මොකක් හරි ගමනක් යන වෙලාවක මොකක් හරි එහෙම වෙලාවක පවා ලෙසන් එක බලාගෙන ඉන්නවා. එහෙම මට අනන්තත් කියලා තියෙනවා මේ සමහර ළමයි සර් මම මේ විදිහට ගමනක් යනවා මට අද නෝට් එක ලියන්න බැරි වෙයි හැබැයි මම පාඩම අහන් ඉන්නවා කියලා පාඩමට හරි පාඩමට එහෙම ළමයි ඉන්නවා හරිද එහෙම ළමයි ඉන්න හැබැයි මොකක් හරි චූටි එක්ස්කියුස් එකක් අරගෙන මේ නැවිත් තියෙන කට්ටියක් තියෙනවා හරි ඒක කරන්න එපා ඒක කරන්න එපා කියලා කියන්නේ ඒක වාඩම හරියි ඕගොල්ලොන් තමයි ප්‍රශ්නේ වැඩි වෙන්නේ මොකද ලෙසන් එක පුතේ එවෙලේ කොට දාගන්න එවෙලේ කොට දාගත්තොත් ඔයාලට මානව ලේසි දැන් උනත් අපේ වැඩ පුතේ එවෙලේ කොට දාගත්තොත් බැලන්ස් එකක් නැතුණම මාර විදිහට මෙන්ටලි රිලැක්ස් එකක් නෙදී අපි දන්නවා අපි සාමාන්‍යයෙන් අපිට ඔය මේ වර්ක් ප්ලේස් එකේ එහෙම ගොඩක් වැඩ වැඩි වුණොත් එහෙම මේ අපි රටක් ගානේ ඇටි ඉවර කරගත්තට පස්සේ මාරු රිලැක්ස්. හැබැයි ඕක නිකන් හරි මගේ අරුණොත් එහෙම ඕක ගොඩ ගැහුනොත් අනේකර පයිලක් වුණොත් මොකද වෙන්නේ? මාරු ස්ට්‍රෙස් එකක් එක තියෙන්නේ. මාරු ස්ට්‍රෙස් එකක් තියෙන්නේ. ඒක ලේසි නෑ ස්ට්‍රෙස් එකට මුහුණ දෙන්න. හරි. ඒ නිසා මේ ඒක පොඩ්ඩක් ඔලුව තියාගන්න. හරි. Okay. Okay. Now the second rule. This is the first rule, then second one. Now, suppose there's an equation. All right. Assume there's an equation. So this is the equation A plus BC equal B squared E minus P over Q. Those are terms. So they have those are some physical quantities. No need to worry about them. This is an example. This is an example. This is an example. So suppose now this is an equation. So in this equation, you have to understand few special features. So if there's an equation, if there's an addition or subtraction, actually we can separate two terms. We can separate two terms by addition or subtraction. That means this is a term. This one also a term. This is a term. This one also a term. Actually, you can get an idea. You can understand what is a term using addition or subtraction. If two physical quantities, or if two expressions, normally we can call them as expression. If two expressions are separated by addition or subtraction, this one is called a term. So this is a term, this one also a term. This is term 1, this is term 2. Therefore, this is the third term, term 3. This is term 4. Therefore, we can determine what are the terms in this equation. Therefore, all the terms are separated by addition or subtraction. All the terms are separated by addition or subtraction. Is that clear? Is that clear? If it is clear, please raise the hand. If it is clear, please raise the hand. How to identify a term? If you can identify a term, please raise the hand. One other example. Now tell me what are the terms? What are terms in this equation? What are terms in this equation? My equation is what in terms?
A plus B, one term. Sorry, A one term, B one term. Then A plus B over C is another term. Then DE one term.
P one term.
Then P and Q, two separate terms.
Yes.
Then P minus Q over Z, another term.
Very small mistake with it. You don't want to separately consider this one. Actually, you can do two methods. There are two methods here. There are two methods. And first thing, you can separately divide. You can separately divide this one. A plus B over C means this is equal to A over C plus B over C. Therefore, without considering this division, you can think like this. A over C plus B over C minus DE. Here you can think P over Z minus Q over Z. Q over Z. Therefore, this is a one term. A over C is a one term. B over C is a one term. Okay. B over C is a one term. DE is a one term. P over Z is a one term. Q over Z is a one term. You can think like this. Is that clear? Is that clear with it? If it is clear, please raise the hand. This is a single term. This is another term. This is another term. Right? Those are terms. T1, T2, T3, T4, T5. Or otherwise, you can think this one as a term. This one as a term. A plus B over C is a single term. Then D is a single term. This entire part is a term. Because there's a division. There's a division. A plus B over C is a division. And you know A plus B means addition or subtraction cannot be done among two different physical quantities. Therefore, there is a same physical quantity. Actually, there are two same physical quantities. A plus B means that is a same physical quantity. Okay? Therefore, this one is a single physical quantity. Therefore, you can consider this one as a single term. This one as a single term, this one as a single term. Because there is a multiplication and division on it. Make an entire term, make some pool term. Or else, you can consider this one separately. You can consider this one separately. Therefore, you can think A plus B over C. A plus B over C means that is the entire division here. Entire division here would say. Therefore, this one has a single term, this one has a single term, this one has a single term. And so within this term, there are two terms. Within this term, there are two terms. But you know, according to our previous rule, these two are the same physical quantities. These two are the same physical quantities. Therefore, instead of considering two single terms, we can consider it as a, if suppose this is a velocity, this one also a velocity. Therefore, in numerator, there's a velocity. There's a velocity. We can think like this. Therefore, we can consider this one as a single term, this one as a single term, and this one as a single term. Important thing is, there is a term inside this term. There are two different, two same terms. Different. Two terms in this, within the term. එහෙම කරන්න පුළුවන්. මේ term එක ඇතුලේ තව terms දෙකක් තියෙනවා. මේ term එකේ තව terms දෙකක් තියෙනවා. එහෙම කරන්න පුළුවන්. එහෙම කරන්න පුළුවන්. එහෙම නැත්නම් මෙහෙම කරන්න පුළුවන්. If it is clear, please raise the hand. තේරුණාද උසන්? You know, everyone, please listen to me very carefully. This is the most important thing. You know, according to our definition, two terms are separated by addition or subtraction. No, two terms are separated by addition or subtraction. Is that clear? Two terms are separated by addition or subtraction. Therefore, according to our first rule, addition or subtraction can be done between two same physical quantities only. Two same physical quantities only. Therefore, this term should be equal to this term. That means dimension of this term should be equal to dimension of this term. Not only this, these dimensions should be equal to this term and this one. Therefore, addition or subtraction can be done among two same physical quantities. If I apply that rule into this one, there's addition between them. Therefore, these two physical quantities should be equal. There's an equation mark in my mark. Therefore, that one should be equal to this one also, and this one also equal to this one. Therefore, on the other hand, if there is an equation, all the terms in the equation should have same dimension. All the terms in an equation should have same dimension, because addition or subtraction can be done among two same physical quantities. According to that rule, all the terms in an equation should have same dimension. If it is clear, please raise the hand. Hey, Therefore, dimension of A should be equal dimension of BC. That should be equal dimension of D squared E, and that should be equal dimension of POQ. All the terms in an equation should have same dimension. All the terms in an equation should have same dimension. That is because two terms are separated by addition or subtraction. We cannot add or subtract two different physical quantities. Therefore, this one should be equal to this one. Equal means dimension, not value. Value එක නෙමෙයි මේ equate කරන්නේ dimension එකනේ. Dimension. Okay. This is the second rule. මේක දාගන්න. Second rule එක දාගන්න මේක. මේක මම විස්තර කරලා තියෙනවා පුතේ tute එකේ. So I have given the note පුතේ in the tute there in the note. Therefore no need to write any sentence here or paragraph here. Just write this example. Okay. Now we have discussed two rules for it. Now we have discussed two rules in dimensional analysis. Now we can apply those two rules in application, in an application to it. Shall I erase this one? Shall I erase? Okay. Now, this is the first application in dimensional analysis. This is the first application in dimensional analysis. That means actual dimensional analysis can be used to determine the accuracy of an formula or an equation. Therefore, dimensional analysis can be used to evaluate the accuracy of an equation. Accuracy of an equation. And therefore, dimensional analysis can be used to evaluate the accuracy of an equation. So in that case, we have to use our first two rules for it. We have to use first two rules. Using first two rules, you can determine the accuracy of an equation. You can determine the accuracy of an equation. How to do that? How to do that? How to do that? Suppose you are given this equation. F equal M is square. M is square. We got that again. And another thing is you are given S equal ut plus half at square. Half at square. Half at square. And okay. Suppose you are given this kind of equation. This is first equation, first rule is addition or subtraction can be done among two same physical quantities. Second one is all the terms in an equation should have same dimension. And the third one, you have to understand the third one also, that is numbers. Numbers do not have dimensions. Numbers do not have dimension. Numbers. That means number means just a number. Number means like this. Half is a number. They do not have dimension. Dimension means that is the relationship between the derived physical quantity and the corresponding physical quantity. Number is not a physical quantity, just a number. Therefore, numbers do not have dimension because they are not physical quantities. They are not physical quantities. Therefore, they do not have dimension. Therefore, if there is a number, we can neglect that thing. We can neglect that thing. Actually, we cannot define a dimension for number. And is that clear? Numbers do not have dimension. Is that clear? Because numbers are not physical quantities. Numbers are not physical quantities. But dimensions means that is the representation of the relationship between a certain physical quantity and the basic physical quantities. Therefore, if we write a dimension for any quantity, there should be a physical quantity. There should be a physical quantity. Numbers are not physical quantities. Therefore, there is no relationship between numbers and any other physical quantities. And therefore, numbers do not have dimension. Numbers do not have dimension. That is the third rule. That is the third rule. Suppose now you are given this kind of equation. Now you are given this kind of equation. So if this is the equation, if this is a correct equation, actually this equation should comply with dimensional analysis rules. Dimensional analysis rule. On the other words, now there are three terms. Now there are three terms. There are three terms. Definitely, dimensions of these three terms should be equal. Because you know, if it is a correct equation, all the terms in that equation should have same dimension. All the terms in that equation should have same dimension. Here you know, this is a one term. This one also another term. This one also another term. No need to consider about half. There is a number. And therefore, those are the terms in this equation. If it is a correct equation, all the terms in that equation should have same dimension. All the terms in that equation should have same dimension. Is that correct? Is that clear? Make a hurry equation may have a term dimension. Is that clear? If it is clear, please raise the hand. Therefore, dimension of displacement. This is S means displacement. S means displacement. U means velocity. A means acceleration. T means time. So S is the displacement. Therefore, its dimension should be equal to L. Make on term UT. The second term is UT. Now you can determine the dimension of UT. Dimension of UT. Dimension of UT means dimension of U into dimension of time. Dimension of U. U means velocity. U means velocity. Tell me quickly, what is the dimension of velocity? Tagdal here. Give me the answer. What is the dimension of velocity? What is the dimension of velocity? Yes, LT. Capital, capital. LT minus 1. Dimension of velocity is LT minus 1. It should be multiplied with dimension of time. Dimension of time is T. Dimension of time is T. Therefore, T minus 1 T will be cancelled out. Therefore, dimension of UT is equal L. Dimension of S is equal L. Dimension of UT is equal L. Both are matched. Then dimension of AT is squared. That is equal dimension of acceleration into dimension of time square. So what is the dimension of acceleration? Dimension of acceleration? Yes, LT minus 2. Very good. Okay, LT minus 2. Dimension of time is square. Dimension of time is square means T square. T square. Again, minus 2 to plus 2 will be cancelled out. Therefore, dimension of AT square is equal to L. Here, third one. Therefore, from first, second, and third equation, it is very clear. Dimension of S, dimension of UT, dimension of AT square. All are equal to L. All are equal to L. That means all the terms have same dimension. All the terms have the same dimension. Therefore, dimension of S is equal dimension of AT square equal dimension of UT. Then I can write, therefore, all the terms in this equation have the same dimension. So, this equation is dimensionally correct. This equation is dimensionally correct. Dimensionally correct. dimensional මේ equation එකේ කිසිම ප්‍රශ්නයක් නැහැ කියලා කියන්න පුළුවන්. මම කියන්නම් එහෙම මම කිව්වේ කියලා. Therefore, this equation is dimensionally correct equation. Is that clear? If it is clear, please raise the hand. Hey, mana person. No, this is the correct way. This is the correct way. මම මෙතන කියන්න අනිත් පැත්තේ මොකද මේ ගොඩක් වෙලාට කියා දෙන විදිහත් මම මෙතන කියා දෙන්නේ. Okay. Now look into this one. Now look into this one. මම මේක සෙකන්ඩ් කියා දෙන්න හේතුවක් මම කියන්න. Now look in this. Now tell me how to solve this one. How to solve this one? How to solve this one? Now tell me in this equation what are the terms, Puti? What are the terms? In this equation, what are the terms? What are the terms, Puti? Again, my equation what are terms here?
FMA squared.
First term is F, Puti. First term is F. This is the term. Is there any addition, no subtraction in between M and A square?
Yes, multiplication.
There's a multiplication means that may actually two terms are separated by addition or subtraction only, Puti. Therefore, if there's a multiplication, it is not matter. It is not a matter. Therefore, this is a single term. This is a single term. This is a term 2. Term 1, term 2. And this is a term. This is a single term. There's a multiplication only. This is a single term. Those are single term. Two terms are separated by addition or subtraction. Addition or subtraction. Yes, Pate. Yes. So we are called this kind of equation are single term equation. Single term equation means in left hand side and right hand side. In both sides, there are one term only. There are one terms only. There is a one term only. Here's left hand side, there's only one term. Right hand side, there's only one term. Here, left hand side, there's only one term, but right hand side, there are multiple terms with it. There are two terms. Therefore, we call this kind of equations are multiple term equation. These are single term equation. These are single term equation. There's only one term in one side. One term in one side. But according to our basic concept, all the terms should have same dimension. All the terms should have same dimension. Therefore, here I can write the dimension of F. Dimension of F means dimension of force put there. That is MLT minus 2. Then dimension of MA square. Dimension of MA square of M is put a mass. A square is square of this one, that means L to the power 2, T to the power minus 4. Square of this one, square of this one, A to the power 2, T to the power minus 4. Now it is very clear. Dimension of F is not equal. Dimension of F is not equal dimension of MA square. MA square. Therefore, this equation is incorrect equation. This is an incorrect equation. Because if it is an equation, all the terms in that equation should have same dimension, but this equation is not satisfy that basis requirement. Due to this reason, this equation is not a correct one. This is an incorrect one. Is that clear? Then I can write this is incorrect equation because all the terms in this equation have not the same dimension. Same dimension. Is that clear? If it is clear, please raise the hand. They know how to sign. But then මෙතන අපි මේ if you are given this kind of equation මේ actually මේ accuracy කියලා දෙනකොට පුංචි දෙයක් තියෙනවා කියලා දෙනකොට ඔක මේ පොඩක් අර වෙනස් විදිහට කියලා දෙන ආකාරයක් තියෙනවා. ඒ තමයි left hand side එකේ dimensions right hand side එකේ dimensions වලට equal වෙනවා කියලා. හරි ඒක හරි වැරද්දක් නැහැ. ඒක හරි. The left hand the dimension of left hand side should be equal to dimension of right hand side. That is okay. And that is okay, but that is okay for single terms equation. In single term equation, there's only one term. Therefore, then we can equate cos and ma squared may separately put it. So in that case, we can tell dimension of left hand side is equal dimension of right hand side. But if you are given multiple term equation, so how to equate left hand side and right hand side? How to equate left hand side and right hand side? Is a වැරද්දක් නැහැ. ඒ කියන එකේ වැරද්දක් නැහැ. left hand side එකේ right hand side එකේ dimensions equal වෙන්න ඕනේ කියන එකේ වැරද්දක් නැහැ. හැබැයි ඒක වැරදි නැති වුණාට අර හැමතැනම පාවිච්චි කරන්න පුළුවන් දෙයක් නෙවෙයි. හරිම නැහැ. ඒකයි. හරිම කතන්දරේ. The correct name is if it is an equation, all the terms in the equation should have same dimension. All the terms in that equation should have same dimension. If so, no need to worry about left hand side and right hand side, because all the terms should have same dimension. So if you consider all the terms, if you consider all the terms, and if you can show whether they have same dimension or not, then no need to worry about left hand side or right hand side. And therefore, if there's an equation, definitely all the terms in that equation should have same dimension. All the terms in that equation should have same dimension. Is that clear? If it is clear, please raise the hand. පැහැදිලි නැති සංගීතය. ඔව් පුතෝ. එච්චර හිතන්න නෑ. මේක left hand side right hand side දෙකලින් දාන්නතෝ terms ගැන හිතලා වැඩේ කරන්න. එහෙම එකක් වැරද්දක් නෑ single terms එක. බලමු අපි කතා කරමු. Okay, you can write this application number one. Fine. Application number one. Determine the accuracy of an equation. Determine the accuracy of an equation. You can write these two examples. This is example number one. This one example number two. once you determine the once you determine the dimension of each term, then you can check whether they are equal or not. If they are equal, then you can write all the terms have the same dimension. Therefore, this equation is dimensionally correct. Dimensionally correct. Dimensionally correct. This word, this sentence should be there. Dimensionally correct. I will.
Dimension.
Sorry, Uday? Yes, Uday.
Yeah, it's okay, sir. Correct. Okay, sir.
Correct. Yeah.
So velocity is ms minus 1. Velocity is ms minus 1 also, but that you are taking only length only, sir. How we can take like that?
Sorry, Uday?
Velocity is ms minus 1 no velocity, the unit. But here you are taking only the length, the numerator part only, yeah? The velocity.
No, no. Here, velocity into time.
Yeah,
Velocity is LT minus 1. That is correct.
velocity, yeah, okay.
LT minus 1 into
Ah,
time. Okay?
into time, that time,
Into
right.
time. Once you multiply with time, minus 1 to plus 1 will
Ah,
be cancelled out.
right, sir,
Right?
right, right.
Then it will be the
Right.
velocity into time. Dimension of velocity into time is important.
Mm.
Huh?
Okay.
How about it? I finish.
So dimension means unit, no, sir, the unit, right?
Sorry?
Dimension means the unit, no? Unit, no? That the basic unit, no?
No, dimension is not unit potential.
The symbol of the basic unit. The symbol
Huh?
of the basic unit.
No, actually, this is a symbolical representation of the relationship between a particular physical quantity and the basic physical quantity. Huh?
Mm.
That is not unit.
Not unit.
Actually, using the unit, we can determine dimension, but that is not valid for every physical quantity.
Mhm.
Because some physical quantity, especially in angles, angles have a unit,
Mhm.
but it doesn't have any dimension. Angles has no dimension, but it has a unit. Therefore, unit and dimensions are two different things. Two different things.
Mm.
Unit means that is the scale. That is the scale we use to measure that physical quantity. Dimension means that is a symbol. That is a symbolic representation of the relationship. That is a symbolic representation of the relationship between a physical quantity and basic physical quantity.
Mm.
So if we consider about velocity, actually velocity can be, velocity is equal to displacement over time. Displacement over time. Therefore, if you want to represent the relationship velocity, you have to write this equation. No? This is the relationship between velocity and the basic physical quantities. Therefore, if you are asked to write the relationship of velocity between the basic physical quantity, you have to write this equation. So that is a lengthy way. There's a lengthy way. Therefore, instead of writing the equation, you can symbolically represent it. How to symbolically represent it? You can use English letters instead of full name. Instead of full name. Therefore, first we have to define some standard symbol for basic physical quantities. Basic physical quantity. Then, according to this basic physical quantity, according to those symbols, then we can symbolically represent the relationship between the basic physical quantity and derived physical quantity. And actually, instead of writing displacement, as it is a length, I can write it has a without writing time, as is it time, I can write it as capability. So this representation is called the dimension. Therefore, dimension of velocity is equal L t minus 1. From that, I can say dimension of velocity is L t minus 1. That means velocity is equal to a length over time. That is the understanding we can get from this dimensional formula. From this dimensional formula, I can get an understanding velocity. The velocity is equal to a length over time. Length over time. Actually, I don't know what is the length is. I don't know what is time is. Therefore, this is not an equation. But that is the relationship between the velocity and the basic physical quantity. So this is the relationship only. Therefore, this is not an formula. This is not a formula. And actually, we cannot get a value for velocity using this formula. The formula is velocity value. So this is a symbolic representation only. And from that, I can say velocity is equal to a length over time. I don't know whether the length is a displacement, whether the length is a distance. I don't know that thing. I can say This is equal to length over time only. Is that clear?
Yes, sir. Yes, sir.
Therefore, dimension means that is a symbolic representation of a relationship. This is a symbolic representation of a relationship between a certain physical quantity and the basic physical quantities. So this is most of the cases. This is we can get the dimension using unit also, but there is not a correct way. There is not a correct way. Unit use කරලා dimensions ගන්න පුළුවන්. There is okay with it, but there is not accurate for every physical quantity, because there are some physical quantity they do not have dimensions. As an example, angles. Angles do not have dimension. They do not have dimension, but they have sorry, but they have a unit with it. Angle එකට unit එකක් තියෙනවා. Angles may have unit, but they do not have dimension. Therefore, we cannot write the dimension referring the unit with it, because there are some units. There are some cases, some physical quantities have unit, but they do not have dimension. Therefore, when you are writing the dimension, you have to have the relationship. First, you have to have a relationship. Then this relationship is converted into a symbol. This relationship is converted into symbol. That is called dimensional formula. That is called dimensional formula. Etc. Is that clear?
Yes, sir.
Okay. So if it is an equation can be divided into two main categories. One is single term equation. Other one is multiple term. Multiple terms mean more than one term in one side. One term in one side. Single term is this kind of one. A equal B. A equal B or A equal BC right now. Multiplication. Then actual equation actual equation F equal M. Multiple term is S equal UT plus. If you are given any term, if you are given an equation with any term, you can use that basic argument. What is the argument for that? All the terms in that equation should have same dimension. All the terms in that equation should have same dimension. Therefore, if they are dimensionally correct, then definitely the dimension of F should be equal to dimension of M. Because there are only two terms. There are only one term in left hand side, one term in right hand side. Therefore, you have to equate the dimension of left hand side into dimension of right hand side. Dimension of left hand side into dimension of right hand side. Therefore, if you are given a single term equation, then you can find the dimension of left hand side. Then you can find the dimension of right hand side. If they are equal, then you can say this is a correct equation, dimensionally correct equation. So that is another method. There is another method, but I think the best way means use the basic. Use the basic. And because if you may use the basic, there's no chance to no chance of may get the incorrect answer with it. Therefore, use the basic concept. Here, if they are dimensional correct equations, then dimension of S should be equal dimension of ut equal dimension of at square. This is the method one. This is method one. Method two is as there are single term in one side, as there's already single term in one side, instead of writing two terms, I can write it as dimension of left hand side and dimension of right hand side. Dimension of left hand side and dimension of right hand side. Then we are not put it. And one side. Dimension of left hand 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 side means dimension of force. Dimension of left hand side means dimension of force only. And dimension of right hand side. In right hand side, there's only one term, that is MA, that is equal to MA. Therefore, if it is dimensionally correct, then I can say dimension of left hand side should be equal to dimension of right hand side. Right? So this is for only single term equation. This is for only single term equation. Otherwise, most accurate way is determining the dimension of each term separately and then determine whether all of them are equal or not. If all of them are equal, then you can say all the terms in this equation have the same dimension. Therefore, this equation is dimensionally correct. Dimensionally correct. Dimensionally correct. Then I can say dimension of LHS is equal dimension of RHS. Then equation is dimensionally correct. But if they are dimensionally correct, මෙන්න මේක වෙන්න ඕනේ. ඒවලට කෙලින්ම ඩොග් ගාලා ඉක්වේට් කරන්න එපා. ඉක්වේට් කරන්න එපා. equal වෙනවද කියලා බලලා තමයි කරන්නේ. හරි, don't equate the dimension of LHS and dimension of RHS or dimension of each term separate each term at the first one. Don't equate them. Don't equate them. First, you have to find the dimension of each term separately. Then, look into their dimensions, determine whether they are equal or not. If they are equal, then you can equate them. Have it. සමහර ළමයි කරනවා මුලින්ම මේක equal කියලා ලියා ගන්න. ලියාගෙන මේක simplify කරනවා. මේකත් simplify කරනවා. මේකත් simplify කරනවා. මැදදී equal නැති වෙච්ච එකම මොකක් ගාලා ගහනවා. Unequal to. That is wrong. Don't equate them at the first. I don't know whether they are equal or not. And therefore, first you have to determine the dimension of each term separately, as mentioned earlier. You have to mention it. You have to find the dimensions separately. Find them separately. Then look into their dimensions. Determine whether they are equal or not. If they are equal, then write this up. Then you can write the equation. Then you can equate them. After that, you can say all the terms have same dimension. Therefore, these equations equation is dimensionally correct. Dimensionally correct. Is that clear? If it is clear, please raise the hand. Okay. Okay. Now look into this equation. Look into this equation. Actually, I use this equation because you know this equation. You know F is equal to F is equal to MA. You know F is equal to MA, F is not equal to MA. But look into this equation. You know this equation is not correct one, no? This is incorrect. Actually, you know F is equal to MA, but F is not equal to MA. No, F is not equal to MA. Definitely F is equal to MA. And no need to worry about the accuracy. This is incorrect equation. But look into the dimensions. Look into the dimensions. Dimension of F is equal MLT minus 2. You know there is no dimension for number. There's no dimension for number, Puti. As numbers do not have dimension, 2 does not, actually 2 has no dimension, Puti. As it has a no dimension, dimension of left-hand side, or 2MA, that also equal MLT minus 2. Because 2 has no dimension. Therefore, in that case, dimension of F and dimension of 2MA both are MLT minus 2. Both are equal in dimensions. But you know, this is a incorrect. Therefore, there's a limitation of this analysis. There's a limitation. This is the limitation. We cannot say whether the equation is 100% correct through this analysis. We cannot say. That is the limitation. Because if there is a numerical factor, if there's a numerical factor in this equation, we cannot evaluate the accuracy of that numerical factor. Because numerical factors do not have dimensions, therefore, dimensionally, we cannot evaluate the accuracy of that numerical factor. You cannot evaluate whether this 2 is correct or not. But you know that is incorrect because you know this equation. But if you are given unknown equation there, then you cannot assure whether this number is accurate or not. You cannot say. දැන් මේක දුන්න නිසා දන්නවා. හැබැයි ඔයා හිතන්නකෝ ජීවිතේට දැකලා තියෙන equation එකක් දෙනවා. And therefore, suppose you are given an equation, that equation you haven't seen that equation before. Suppose there are some numbers in that equation. Therefore, how do you say whether those numbers are correct or not? You cannot say. Therefore, that is the limitation of this analysis, Puti. That is the limitation of this analysis. And actually, we cannot evaluate the accuracy of numerical factors. Because they do not have dimensions. They do not have dimensions. And okay. Therefore, we can say only one thing. If there's an equation, if their dimensions are okay, That's why I want to say, I want to write this one. This equation is dimensionally correct. You can say only that. You can say whether the equation is dimensionally correct or not. If that equation is dimensionally correct, then there is a possibility to that equation is correct. ඒ කියන්නේ equation එක dimensionally correct නම් පුතේ ඒතර possibility එකක් තියෙනවා මෙයා correct වෙන්න. හරි. ඒක අවුලක් නෑ half එක ඉතින් dimensionally correct half is okay පුතේ. There is a correct equation. But yet we cannot analyze this one. That is the reason you have to write that word. You have to write that word. If all the dimensions are equal, although all the dimensions are equal, you cannot say this equation is correct. Therefore, you can only say one thing: this equation is dimensionally correct. That means all the terms have same dimension. Therefore, this equation is dimensionally correct. So you can determine the accuracy of dimensions of that equation only. Is that correct? If it is okay, please raise the hand. නිසා මේ වගේ එකක් ආව ගමන් equation එක dimensionally okay වෙච්ච ගමන් මට කියන්න පුළුවන් මේක dimensionally correct කියලා විතරයි. ඒ වෙනකොට ඩෝංගල කියන්නේවා this equation is correct කියලා. ඩෝංගල කියන්නේවා this equation is correct කියලා because we don't know. We don't know that thing. We don't know whether this equation is correct or not. Therefore, if you have equal dimensions in each term, you have to write that word. This equation is dimensionally correct because you can say that thing only. You can say that thing only. Is that clear? If it is clear, please raise the hand. තේරුණා පුස්සන්. ඒක තේරුණා පුස්සන්. පැහැදිලිද? If it is okay, please raise the hand. Okay, thank you. Chris, okay. If there's an incorrect dimension, if there's an incorrect dimension, therefore definitely that equation is incorrect. නේ dimension වැරදිලා පුතේ ආයි බලන්න දෙයක් නැහැ numerical factors තියෙන. එහෙනම් ඒක කොහොමද කරන්නේ? So if there's an incorrect dimensionally incorrect term, therefore no need to worry about the accuracy. Definitely the equation is inaccurate input. Therefore, if there is a dimensionally unmatching term, that means this equation is not accurate. And therefore, if the dimensions are not accurate, then we can definitely say this equation is not accurate. But if you have equal dimensions in every term, there's a limitation of numbers. And therefore, when you are analyzing the accuracy of an equation, if you have the same dimension for every term, then you have to write that one. You have to write that word. This equation is dimensionally correct. That is the only thing you can say. That is the limitation of this analysis. Here, if you get this application, please raise the hand. Equation එක fake කියන්න පුළුවන් ඉතින් dimensionally match වෙන්නේ නැත්නම් පුතේ ඒක fake. Dimensionally match වෙන්නේ නැත්නම් fake. හරිද? ඊළඟට dimensionally match වුණොත් එහෙම මේක fake ද නැද්ද කියන dimensionally බෑ. හැබැයි ඊට පස්සේ experiment කරලා කරන්න පුළුවන්. හරිද? make f equal to ma. Suppose f equal to ma, whether actually if you want to find the accuracy accurately, if you want to find the accuracy accurately, then you have to do some experimental thing regarding the numerical factors. You have to do some experimental procedures to evaluate the numerical factors. And otherwise, you cannot say whether this equation is 100% correct or not. And you can only say this equation is dimensionally correct. That is the only thing. 100% correct නැද්ද කියලා බලා ගන්න අනිවාර්යෙන් වා එක්ස්පෙරිමන්ට් එකක් කරන්න ඕනේ. එක්ස්පෙරිමන්ට් එකක් කරන්නේ නැතුව ඒකවත් කියන්න බෑ. හරි. වැරදි නම් කියන්න පුළුවන්. වැරදි නම් කියන්න පුළුවන්. මොකද dimensionally incorrect නම් බුද එතනින් හැර කතා කරලා වැඩක් නැහැ. හරි. dimensionally incorrect නම් එතනින් හැර කතා කරලා වැඩක් නැහැ. හරි. Okay. Clear? Okay, take the tube, put it. Take the tube take again. Then there are some essay questions. There are some essay questions. The second essay question, which is in page 19. The second essay question, which is in page 19. Second essay question, which is in page 19, in the tute, not the not, tute. Tute. Before doing the second essay question, you have to write this one. You have to write this one in the notebook. Notebook එක මේක දාගන්න මේක ලියගන්න තමයි. Then there are 10 questions. There are 10 questions පුතේ. First one is s equal ut plus half at squared, v equal u plus at, v equal u squared plus 2as. Those are the equations. You have to determine whether they are accurate or not. Whether they are accurate or not. And the physical quantity representing in each English word are mentioned in the above පුතේ. අර උඩින් දාලා තියෙනවා. English letters වලින් mention කරන physical quantities උඩින් දාලා තියෙනවා. Okay. Now you have to write this one and go through the questions. Go through the questions. Go through the questions. Okay, first one is done. First one is done. The second thing, second one. V equal U plus 80. Have finished? Have finished. Make a clear now, Tusan. If you complete the second one, please raise your hand. If you complete the second one, please raise the hand. Okay, Kaushik. Yes, okay. Okay. Hurry. Then check your answer. Now there are three terms, no? Now there are three terms. One is this one. This is a term one. This is term two. Okay? Because these two terms are separated by this plus mark. Plus mark. Therefore, this one is term three. There are three terms. There are three terms. Now we can determine the dimension of each term separately. Dimension of first term is V. That is a velocity. V is given as a velocity. V is given as a velocity put there. Therefore, dimension is LT minus 1. Dimension of U. U also a velocity. U also a velocity. It is given put there in the question. Therefore, the dimension of velocity is LT minus 1. The dimension of acceleration into time. Dimension of acceleration into time. So what is the dimension of acceleration? Tell me, what is the dimension of acceleration? Acceleration into time. What is the dimension of acceleration? Dimension of acceleration? L t minus 2. L t minus 2. Yes. L t minus 2 multiplied by 3. T means time. Then minus t to 1. T is will be cancelled out to there. Therefore, this is L t minus 1. This is triangle. Now it is very clear from first one, second one, third one, all the dimensions are equal. Therefore, dimensions of all terms in this equation are equal. Therefore, dimension of V is equal dimension of U, that is equal dimension of AT. Therefore, this equation, normally then, this equation is dimensionally correct. Dimensionally. Correct. Because all terms have the same dimension. Is that okay? If you got this answer, if you write this way, please raise hand. May there you wanna may there got Atusan. Right that? This is the answer. Hello, Chris.
Yes, sir.
Thank you. Third one, V equal U square plus 2As. V equal U square plus 2As. Third one. V equal U square plus 2As. So you have to determine the dimensions of each term separately. Each term separately, then dimension of V. That is a velocity v, that is lt minus 1. Then dimension of u square. Dimension of u square. Dimension of u square is equal. U means put a velocity. This is equal. Dimension of u square. Dimension of u means lt minus 1. Lt minus 1. U square. That means L square into t minus 2. So no need to determine the dimension of 2 ways put it, because it is very clear these two are not equal. These two are not equal. That means all the terms of this equation do not have the same dimension. Dimensionally incorrect. Therefore, this equation is an incorrect equation. This equation is an incorrect equation. Then you can write this one. Dimension of V is not equal dimension of u square. Therefore, all terms do not have the same dimension. Therefore, all terms do not have same dimension. Therefore, this is an incorrect equation. This is an incorrect equation. Right. If you got these answers, please raise the hand. Maybe there will not question. Someone over 2 ways for another take question. But if you write in this way, please raise the hand. So after completion of this session, please send your answers. Please send your answers because I need to check them. Okay? I need to check them. Okay? All of them should send your answers to me. All of them. Therefore, after completion of this session, please send your note to me. මොකද වැරද්දක් තිබ්බම දැන් මම දන්නවලු පුතේ නැත්තම් ආයි අර මේ අපි කියන පහු වෙනවා කියලා. එහෙම වුණාට පස්සේ හදන්න බෑ. දැම්ම හදලා දාන්න ඕනේ. Okay, fourth number. I have completed. Shall I rest? ටක් දාලා කරමු පොඩ්ඩක් මේ කාලවලට එච්චර හොඳ නැහැ මේ weather condition is not good because there is a thundery situation. Therefore, we have to complete this very quickly. Okay, shall I erase this one? Shall I erase? Okay, if you want to take a screenshot, now you are free to take a screenshot. Tag දාලා ගන්න screenshot එක. ඕන නම් okay. Fourth one, F equal ax square. X means displacement. Mx square. MS square. This is force, mass, displacement. Okay, displacement. Force, mass, and displacement. Then dimension of force. You know dimension of force. What is the dimension of force? Taka here. Dimension of force. What is the dimension of force? Dimension of force.
I can write mass into acceleration and get the dimensions of that, no?
Yeah, but if you can remember, it will be much better. Because you have force, pressure, area, density. Those are some regular physical quantities. That means those are, we have to use them regularly. Therefore, you have to remember their dimension. It will be much better because you have to improve your timing. And you have to improve your timing. Therefore, try to remember that thing. MLT minus 2. MLT minus 2. No issue, eh? Still, now you can write the equation and take the dimension. But no issue because until you remember, you have to do like this. And but try to remember them. Try to remember them. It will be much better to improve your timing. Okay. Then this is the first term, this is second term. The second term is entire mx square. Entire part. M is mass. Then x means that is a length, displacement, that is a length. Length is square, m is square. Therefore, it is very clear dimension of force is not equal dimension of mx square. Therefore, dimension of all terms in this equation is not equal. Therefore, all terms do not have same dimension. Therefore, equation is not correct. Not correct. Or incorrect. Equation is simple. If you got this one, please raise the hand. Please raise the hand. मेरे दफ्तर का क्वेश्चन ඊළඟට fifth one f is equal kx. Here k is spin constant. Spin constant. So if you have done the previous question, that means if you have determined the dimensions of each physical quantity. In the first question, actually, in the first question, you have to do, you have to find the dimension of each physical quantity. So if you go through that question, then there was a spring constant, then you can apply that value. And so dimension of spring constant. Dimension of spring constant is equal m t minus 2. මේ equation එක තමයි ගන්න ඉතින් මේ equation එක හරි. That is mt minus 2. I will explain what is spring constant. Then dimension of f is equal mlt minus 2. Then dimension of kx, that is equal k dimension of k into dimension of x. Dimension of k, dimension of spring constant is mt minus 2 put it. Mt minus 2. Dimension of x means it is a displacement. Displacement, therefore it is L. Dimension of x is equal to L. Therefore, answer is M L T minus 2. MLT minus 2. MLT minus 2. Therefore, it is very clear. Dimension of force is MLT minus 2. Dimension of kx also equal MLT minus 2. Therefore, dimension of f is equal dimension of kx to k. Therefore, it is very clear all terms in this equation have the same dimension. Therefore, all terms have the same dimension. Therefore, equation is dimensionally correct. Equation is dimensionally correct. Is that clear? Okay, now I have done 5 questions. I have done 5 questions. Then you have to do question number 6 to 10. Question number 6 to 10. If there's any new physical quantity, I think there's no any new physical quantity. No, there's no any new physical quantity. There's no any new physical quantity. E means energy. If you couldn't remember the dimension, if you couldn't remember the dimension of that physical quantity, then go to the first page. Go to the first page. Then there is a relationship. There's a relationship. Then you can determine the dimension from that relationship. And මතක නැත්නම් first page එකට යන tube එකේ. First page එකේ තියෙනවා equation එක. The energy එක නම් energy එක කොහොමද හොයන්නේ? If you cannot remember the dimension of energy, then go to the first page. Then there's the equation to determine energy. Then you can determine the dimension of energy using that equation. Okay. Then do the question number 6 to 10. 6 to 10. Once you read the question number 6 to 10, once you read the question number 6 to 10, then please may upload your answers to the group, okay, registered group. Please upload your answers to the registered group. Then I can check. Okay. Okay, with it. Have finished? Is it clear? There's no is it? In the second question, there's no is it? No. In the second question, there's no is it? No. You have the second question only. Have finished the second question? There are 10 questions, no? There are 10 sub questions in the second question. Have finished? Have finished. Okay, Chris. Your answer is correct. Your answer is correct. Right there. Okay. Correct. Okay, but now we have discussed 3 rules in dimensional analysis. First rule is addition or subtraction. The second thing is all terms in an equation should have set dimension. Then third one is dimension of a number. Dimension of a number is equal to 1 or it has no dimension. It has no dimension. Those are 3 equations. Then those are 3 rules, but there are another 6 rules per day, altogether 9 rules. Then the fourth you have to send me the answers today. You have to send me the answers. I need to check your answers one by one. And I have to check the answers of each student. I have to check the answers of each student today. Therefore, please send your answers to me. And then the fourth part. Meanwhile, I do the fourth rule. The fourth rule is a power. Power. Everyone, please look at me. Power. You know this one. So what is the meaning of power? 2 to the power 7 this This 2 to the power 5. What is the meaning of power? What is the meaning of power? Power or index? Index. What is the meaning of index? Index क्या निकालते हैं? Suppose now there's a multiplication. Suppose there's a multiplication of 2 by itself in several times. Suppose there is a multiplication of 2 or any number by its own value in several times. And so in this case, there are only 5 times put there. There are only 5 times. Therefore, if we write this one in this way, that is a very long way. That is very long way. Actually, there are only 5 may to say put there, but sometimes there may be 100 twos, 1000 twos. How to write them? That is very unnecessary thing put there. Therefore, if any number is multiplied by its own value in several times, actually it is very lengthy way to write that thing like this. Therefore, there should be a short method to represent this multiplication. So in that case, we represent this multiplication using an index. Index. This can be written as there are 1, 2, 3, 4, 5. 2 to the power 5. 2 to the power 5. Therefore, 2 to the power 5 means this number we call it as base. This number which is base is multiplied by its own value in 5 times. In 5 times. Therefore, this is the index. The index is equal to the number of times. Number of times. Number of times. Actually, number of times the 2 is multiplied by its own value. Therefore, index is equal to number of time. Number of time is that is a number. It doesn't just number. It is not just a number. Therefore, if there is an index, with a index means it is a number. Index is a number. Is that clear? Index is a number. Is that clear? If it is clear, please raise the hand. If there's an index means that is a number. Therefore, the most important thing is, number has no dimension. Numbers has no dimension. Therefore, suppose now there is a expression like this. A to the power bt. Suppose t is a time. So, now index is a number. Therefore, if there is an expression, as an index, that expression should be a number. Therefore, suppose there is an expression here. Suppose if there's an expression here as an index. Suppose if there is an expression, as an index, that expression should be a number. It should be a number. Therefore, this one is a number. Therefore, here now a to the power bt plus c. A to the power bt plus c. That means this part is the index. This is the index. You know, index means that is number. Index is a number. Therefore, dimension of index should be equal to dimension of number. You know, dimension number doesn't have, they do not have dimensions with it. Therefore, dimension of an index has no, dimension of an index should be equal to 1 or it has no dimension. It has no dimension. Therefore, if there is an expression, as an index, if there's an expression as an index, this expression, that means bt plus c, this is the index put in. Therefore, this expression should be a number. This expression should be a number. Is that clear? This expression should be a number. Is that clear? If it is clear, please raise the hand. Now you know bt plus c is a number. Bt plus c is a number. And you know, according to our previous rule, in the first rule, actual addition or subtraction can be done among two similar physical quantity. In the other words, in the second rule, all the terms in an equation, should have same dimension. All the terms in an equation should have same dimension. That means now you know this one is a number, this is a confirmed one, this is a number. Therefore, this C, this is the second term. That should be a number too. This is a number. This one also a number, Puti. Therefore, according to our second rule, this term should be a number as well as this term should be a number because this is a number. This is a number. Therefore, according to the second rule, all the terms in an equation, should have same dimension. Therefore, all the terms in an equation should be the same physical quantity. Therefore, bt, now you know this one is a number, this term is a number, you know this term is a number. Therefore, this term also be a number, this term also a number. And therefore, according to the second rule, dimension of bt should be equal dimension of c, and it should be equal dimension of number. Is that clear? If it is clear, please raise the hand. If it is clear, please raise the hand. Therefore, you know, dimension of number is equal to 1. Dimension of number is equal to 1, no, has no dimension. But if you want to do a mathematical operation, it should be, you have to write it as a 1 to 3. Make a mathematical operation like 1 easy. Therefore, once you equate this one, you can find you can determine the dimension of b. Once you equate these two, you can determine the dimension of c. Therefore, you know, dimension of bt is equal to a number. You know, dimension number is equal to 1 to 3. Therefore, dimension of B into dimension of T is equal 1. That means dimension of B into dimension of T means time kilowatt. Dimension of T is equal capital T is equal 1. That means if you subject dimension of B, that is equal dimension of B is equal 1 over T. 1 over T. That means B is equal T to the power minus 1. Dimension of B is equal T to the power minus 1. Is that clear? If it is clear, please raise the hand. Mom may B get dimension in a whole baker clear Nagatusan, pay Namatusan. I need responses from everyone. Is it okay with it, Chris?
Yes, sir.
Okay, thank you. Then dimension of C, it can be easily determined for the dimension of C, that is equal dimension of number. You know dimension of number, it is equal to 1. Therefore, dimension of C, that is equal to 1. That means it has no dimension. It has no dimension. Therefore, from that we can determine dimension of unknown physical quantity. Therefore, fourth rule is dimension of an index. Dimension of an index. Those are the four. There is a fourth rule. There is a fourth rule. I will check with you. I will check. Right. Okay, Pute. Now we have done 4 rules. Now we have done 4 rules, Pute. Now we can apply those 4 rules into the second application. The first application was determination of accuracy of an equation. Determination of accuracy of an equation. And the second application is this one. What is this one? You can determine the dimension of an unknown physical quantity in an equation using dimensional analysis. This is the most important part in this lesson. Determining the dimension of an unknown physical quantity in an equation. To do, definitely you have to have very good knowledge about the dimensional rules in dimensional analysis. Therefore, sometimes you have to apply more than one rule to analyze that question. And therefore, you have to have very good understanding about rules in dimensional analysis in order to do these kind of questions. Now, the second application, now we are going to do the second application. The second application is finding the dimension of an unknown physical quantity in an equation. It is something like this. Here B is an unknown physical quantity. So we have determined the dimension of B. No? Actually, in that case, I have used fourth rule only, but there are some questions we have to use more. We have to use more than one rule. Actually, I have used more than one rule. Not only fourth rule, but also I have used the second rule. Second rule. This is the second rule. Within person use the second rule. Therefore, most of the cases we have to use the first rule as well as second rule. ඇත්තට එහෙම නෙමෙයි අපි මම යාම එකක් use කරානේ number එකක් use කරා. Actually I have used the third rule also. Therefore, second application, the second application of dimensional analysis is determining the dimension of an unknown physical quantity. Therefore, second application determination of dimension of an unknown physical quantity in an equation. Determination of dimension of an unknown physical quantity in an equation. Okay. Now we can go to the first question. In the third, the first sub question in the third door. Okay, again, this can be actually, this determination can be done according to the given equation. Suppose if you are given a single term equation. Suppose you are given a single term equation. If you are given a single term equation, it is very easy to determine. It is very easy to determine because you can subject the particular physical quantity. That means suppose you are given this kind of equation. F equal mx. MVC. F equal mx. You are given F as force, M as mass. F as force, M is mass. Then you need to determine Z. I don't Z is acceleration. Anyway, you need to determine X. Now this is a single term equation. If you are given a single term equation, then subject the corresponding physical quantity. Here, you have to determine the dimension of Z. You have to determine the dimension of Z. In such cases, you have to subject the particular physical quantity. So if I subject Z, dimension of Z is equal to dimension of F over dimension of F. Now you can apply dimensions of force and mass. Dimension of force and mass into this equation. Dimension of force is mLT minus 2. Dimension of mass is F. Therefore, NPM will be cancelled out. Therefore, dimension of Z is equal LT minus 2. LT minus 2. Therefore, if we are given a single term equation, actually you can subject the particular physical quantity and get the answer. Make a but suppose you are given a multiple term equation. So in such cases, we cannot easily subject a term. We cannot subject a term easily. And because there are more easiest way, they are subjective. So in that case, we can use our rules. Without subjecting, we can determine the dimensions using our rules. Suppose this one. You are given S is equal AT plus half simple AD square. How do you do that? You need to determine dimension of A. I don't know A. You need to determine dimension of B. This is the question. This is the question. You are given S as a displacement. This is a displacement. You are given this one. You are given this one as displacement. This one as time. And this one as acceleration. You are given that. And you need to determine it. So in that case, you cannot subject A, but actually you are not finding the value of A. But therefore, subjecting A is not a correct way to determine the dimension. And here there is okay because this is singleton function. This is singleton equation. Singleton equation and Sata make okay. But here we cannot do. Here we cannot do. So without subjecting things to A, I can use dimensional rules in dimensional analysis. You know, in our second rule, if there's an equation, it says if there's an equation, all the terms in an equation should have same dimension. Therefore, you know that now this is an equation. Therefore, all the terms in this equation should have same dimension. Therefore, dimension of this term should be equal to dimension of displacement. No, dimension of this term is displacement. Therefore, from that argument, I can build a relationship. Dimension of AT should be equal to dimension of displacement. Because all the terms in an equation should have same dimension. Because all terms in an equation should have same dimension. All right. Now you have an equation. Now you can subject it. And therefore, dimension of A into dimension of T is capital T. Dimension of T is capital T. Dimension of S is equal L. Dimension of S means displacement is equal L. So then you have to take this one into here. If you take this one into here, it will be minus T. Therefore, dimension of A is equal L T minus 1. LT minus 1. If you get this explanation, please raise the hand. Kashi, please.
Yes, sir.
Thank you. Okay, then I will topic. The second application, determination of dimension of an unknown physical quantity in an equation. Then these are the two examples. These are the two examples.
80.
Yeah. Actually, when you are determining the dimension of an unknown physical quantity, no need to subject it. You can go through the rules in dimensional analysis, then you can find the dimension. Okay. Then after reading this one, you can take a small break to there. After reading this one, you can take a small break. Then do the questions up to the question number 10. In the third question, there are about 22 questions, 22. There are about 22 questions. Then do the first 10 questions. Do the first 10. Do the first 10. First one is done. Do the first 10. Once you did the first 10, please may send your answers to the group. I will check. No, 7:15 or 7. No, sorry, 5:15. No? Okay. Once you write this one, you can take a small break. Then here. Small break क्या करा मैं गलत questions टाइम थी ना you can check first one around 6 आगे अगर बताएंगे मुझे बराबर you have to take a break. Okay, you have to take a break. Okay, take a break and may go through the questions. Do the questions up to question number 10. Then you can send your answers before 6. Then I will discuss that then around 6. Okay.